everybody, Scott Holstein here with Computrols. Welcome back to the Building Technology Podcast. Today I'm joined by our guest, Mike Donlon. Mike is the Director of Research and Development and one of the owners of Computrols. He received his bachelor's degree in electrical engineering from the University of New Orleans in 1986. He returned to UNO to get his master's degree in engineering and focused his studies on computer vision and image processing. In 1989, he was hired by Computrols as a principal software developer for the original CBAS computer system. Soon afterward, he was invited by the company's founders to become an equity partner. Since then, Mike's duties have been to oversee all software and hardware development for the company, as well as researching and applying new technologies to building automation. His recent areas of interest include machine learning, building system modeling, and open source technologies for building automation. Mike, welcome to the podcast. How are you doing?
Oh, I'm doing great, Scott. I think you're going to have to lose the 1986 reference there. I'm going to pretend like I'm younger than that, but...
You know, I was born in 85, Mike. That's easy math for me.
Okay. No, it's good to be here. I'm glad to talk about this stuff. It's exciting. We're launching products as we speak, you know.
Yeah, right. And that's really what brought this topic up for me. So for our listeners, today we're going to be talking about applying wireless technologies in the built environment, some of the challenges that come along with that, and what you as a facility manager can do to try to mitigate some of those things. Now, Mike, before we get into our topic for today, one thing I want listeners to know is despite your title, Director of Research and Development, and a lot of the lofty accomplishments and things that you do, you actually have a lot of field experience. So as a technician, installing, programming, doing a lot of things in buildings. Can you talk to us a little bit about your history on that side of things?
Yeah, I mean, in the beginning, I was back in the early days, I was the only nerd in the group. And when we rolled products out, I had to go out in buildings and make them work. With larger teams, a lot of engineers can avoid that. I'd like to say I did it out of the goodness of my heart, but really that was the only way to do it. Over the years, as our R&D department has grown, I've wrestled with bringing up new engineers and trying to get them that field experience that will be so valuable to them in product design. And it's always tough. I mean, you don't want a guy just, pulling wire all day. He's not learning a whole lot. But I had the benefit really of, bringing entire buildings online with me and just a handful of techs, and we'd pull long hours back in the early days. But that experience has proven invaluable. I can immediately tell. I actually was on the phone today with a technician asking him about a feature that I thought was a good feature, and sort of bouncing it off of him to see whether or not it would really be useful in the field. So this is a constant thing, but having that knowledge is really valuable to me.
Yeah, absolutely. And I think it gives you a more realistic view of what is not only achievable, but maybe more importantly, what's realistic, in terms of what we can accomplish within the built environment. I think this topic today is a perfect example, which I'd like to get kicked off by talking about some of the obvious pros of wireless. Instead of cons, we'll say challenges, because with every new technology, you're going to run into some road bumps. But what are some of the things? Let's start on the positive side. What are some of the positives that wireless technology is going to bring to building operators?
Well, I mean, immediately there's cost. The wire runs, the copper, the installations not only are with wireless, they're faster, they're less expensive, and they're less disruptive. If you imagine doing a VAV controller install where you pop and seal and tile out, and you're throwing wire across and strapping it, or if you need pipe, and then you got to come down the wall, and in an existing space, you're pulling a wire from the VAV controller down a wall, punching a hole in a wall. If you imagine that wireless counterpart, you still have the VAV work up in the ceiling, but you're sort of isolated to one place. We currently do Wi-Fi back to the system, and then we do Bluetooth Low Energy, which I'm sure we'll get into a little bit, down to these battery-operated wall sensors, which in the perfect case, you literally just need to attach it to the wall, and that's it. There is no wire. So again, in an existing space, that's a much bigger deal. And then you have a phone app, which your phone has Wi-Fi and Bluetooth on it, and our controllers have Wi-Fi and Bluetooth. So configuring and working with field devices, by pulling your phone out of your pocket is just incredibly convenient.
All right. Now, on the other side of the coin, what are some of the challenges you foresee with wireless technology? Obviously, something that we've talked about is wireless has been around for a very long time. Commercial applications just generally come along a little bit slower, but we do learn a lot from those consumer applications that come ahead of us. So based on that, what do you see as some potential challenges with wireless technology in larger scale facilities?
When first approached, and by the way, we've been working on wireless for 5 years, I think. Roy Lynch, the president of the company, came to me and felt very strongly that it was time to really make a push in wireless. And from day one, and the R&D team is tired of hearing me say this, but from day one, I had two concerns: reliability and power. Those are the two that are going to, if we overcome those, life is good. So back in the old days, you would find wireless devices that were, what they call single frequency. It's, like if you remember the guys flying airplanes around with the little remote control, that is never going to cut it in a large building environment. So the new technologies use, fancier word is spread spectrum, but they frequency hop, they jump around to multiple channels. So in case some big powerful radio comes in your neighborhood and starts to clobber that one frequency, you jump over to another frequency. So all of those, all of the new technologies have that. We didn't want to just settle for, an old school radio that works in the lab, but, you deploy thousands of them and there's going to be reliability issues. The second point, the power, if a device requires power, often that means you're going to run power wire to that device. So eliminating the communication wire doesn't do you a whole lot of good. So in certain cases, you can pick up local power, and local power will be available. For example, at a VAV box, you're turning a motor. Obviously, there's power there. I'm not running power wire to it. But in sensors, we looked at all kinds of stuff. We looked at energy harvesting, solar cells and whatnot, but battery technology has come a long way. And just the cleanest, easiest, most reliable way to do it was to just put batteries on sensors. So we've really, with our new philosophy that we're promoting, sense, connect, control, which we can get into a little bit, sensors are small Bluetooth battery-operated devices that just live by themselves, and we're really happy with the way that they're coming out. They solve the power problem, and they solve the reliability problem. And on our larger controllers and networking devices, we use both Wi-Fi and Bluetooth. But those were the concerns, really, were power and reliability, and we have, to my satisfaction, solved those problems in our design process.
And you mentioned connectivity, which is obviously a huge component of all of this. And you mentioned the potential challenges of connectivity. Can you talk a little bit more about those challenges? And, I know that the noise of having thousands potentially of cell phones in a building can make things difficult. All of these other different Bluetooth and Wi-Fi devices in a building, in the case of a chiller plant or an electrical room, you've got cement walls. Can you talk a little bit about what makes connectivity such a challenge in these environments?
Yeah, well, in your home, people think, oh, well, I do wireless devices all the time. Well, there's, 2, 4, 6 people in a house. The nearest Wi-Fi radio is, 100 feet away or something, maybe your next door neighbors. But when you get into a building, it's very dense. There are thousands of people in a high rise. Every one of them has a phone in their pocket. There are Wi-Fi routers everywhere. There's concrete. You're in the middle of a city. It's a much harsher environment. And we have that's one of the times that I've gotten a lot of the R&D guys out in the field is we run around and we do field tests. So about 2 years ago, we started doing field tests. We were not happy with our first round, but our second round of field testing, I was very happy with. We're getting really good distance measurements and so on and so forth. But the environment, there's no way to test it in a house or in even our office, which is on a highway, and it's kind of spread out. We need to go into buildings to test these things because it's just a very crowded radio environment. However, today's modern wireless radio standards are made for that. I mean, there's a lot of technology over the last couple of decades that has gone into cell phone reliability. If you remember in the early days of cell phone, nobody was going to give up their landline. But now, you don't have a phone in your home. Your cell phone just does everything you need it to do, and it very rarely fails you. So this technology has come a long way, and it's certainly the tech behind it. Behind our products is up to the task of working in large buildings reliably.
So imagine over the last 5 years or so, you've tested out a lot of radio technologies. Can you tell us what are some of the most common types of wireless technology, and where do you see them in application in buildings today?
There are many different standards. Way back in the day, I'll rewind a little bit. When we came out with our first X-line controllers, we had looked at a lot of different technologies, and the internet and the underpinning of the internet is a communication standard called TCP/IP. For those of you not familiar with it, but it's a fantastic networking standard. And commercial networking promoted technologies like Ethernet and TCP/IP, and just the sheer weight of the number of commercial products made that the most attractive because of the economies of scale. Most other building automation companies were going with higher speed serial and all of these just building automation specific technologies, and we chose not to do it. I remember doing a conference years ago, and people were not angry, but just sort of like, how can you put an Ethernet connector on a building automation controller? It's expensive. And my answer was, it won't be in 2 years. And sure enough, it wasn't. And we never really regretted putting Ethernet, TCP/IP connections on every single controller. It's commonplace now, but we wouldn't say ahead of the curve because that technology had evolved. The technology itself was just there for the taking. But fast forward to the wireless days, we're using two technologies that are inside every phone, Bluetooth and Wi-Fi. The Bluetooth part of it, typically Bluetooth was designed for high-speed, one-to-one connections for, home stereo and television equipment and so on and so forth. But when they came out with Bluetooth Low Energy, which is a sort of an offshoot of the primary Bluetooth, and it's made for small battery-operated devices that require extremely low power, when we saw that, it's like, that's it, that's the one. As opposed to Zigbee, for example, nothing wrong with Zigbee, but it's a very industry-specific. The first Zigbee rollout, I believe it was Zigbee 1, we looked at it many years ago, and it had a rough start. I remember going to a Zigbee conference years ago, and my goal was to find someone who has deployed more than 100 Zigbee devices. And the only guy I could find was a guy who owned a gym or a chain of gyms, and they would put Zigbee wireless devices on the machines as people went through the thing. And that was the only one. Everybody else said they had trouble doing it. And I'm like, 100 is the minimum. I'm looking for thousands. And they came out with Zigbee 2.0. It was an improvement. But again, economies of scale, you're just not going to keep up with Bluetooth. So we're employing Wi-Fi and Bluetooth, which are standard commercial, wireless standards, and we're very happy with that decision.
Yeah. So would you say, you really kind of learned a lesson back when you previously had considered what other people were doing in the industry and saw a piece of technology that hadn't quite made its way into building automation or commercial applications yet, but just thought, look, this is long term. This technology is going to advance faster and it's going to be better supported overall?
Oh yeah, I mean that technology just works that way. The thing that is sort of used only by early adopters and low numbers, 5 years is pennies, and buy them anywhere. If you walk, to me it's mind blowing. You go into a Best Buy and you buy a network switch and it costs $17 and it's 10/100 megabit 5-port. It's just mind blowing that if you rewound, I don't know how they do it. I mean, it's unbelievably good value. And anything that's selling in the millions like that is eventually going to reach that point. So yeah, the Wi-Fi and the Bluetooth stuff, even today is just it's just easy. We use these system on a chip computers. I mean, the everything that goes in the larger controllers, they're as good as computers were 10 years ago. And they are a very inexpensive value. And, we use full operating systems. Anytime you try to save a few bucks by peeling off and doing some special industry specific thing, it will get steamrolled by sort of mainstream commercial technology in a few years.
Right. Now, one of the things I'm realizing that didn't come up earlier in our conversation when we were talking about potential challenges of wireless is cybersecurity. And I know I've heard there's obviously a much larger concern about that today than there ever has been. And I think that's not going anywhere. But is that something with wireless technologies? Are there certain wireless technologies that are more secure, or are these all more accessible than a wired network?
The Wi-Fi stuff enjoys the same security technology that networks and buildings enjoy today. So we use TLS security, which is pretty much the standard. There are lots of security standards today. It's just a matter of getting it implemented. Some of the technology that we use today in our controllers for security, TLS and the encryption and all, they require pretty beefy processors and a pretty big stack of code. That stuff is expensive, but if you haven't upgraded your controllers from a decade or so ago to faster processors, you're just not going to be able to implement those security protocols. There are, once again, some industry standard security standards that have been made for building automation, but they really just don't stack up to the stuff that everybody uses. And when you go to an IT department and they ask you, okay, you're going to be a guest on my network, can you tell me your security? And if I just, give them a white paper with TLS on it, they understand it completely. Everybody's on the same page. There's no questions. If I were to break out some, building automation standard, it would not make them feel very comfortable. So all of our products today that we roll out they come with security built in. And I always lecture people, I think of it as a pyramid. You've got at the top of the pyramid, there's some cloud-based software, and then you sort of move down the pyramid to a server that runs a whole building, and then you move down to your large controllers, and then your sensors, and so on and so forth. When you get down to the sensor level, wired sensors or wireless sensors, I'm not saying they shouldn't be secure, but you're talking about someone who's physically in the building and can put their hands on it. It reaches a point where it's silly. Well, they could just take the sensor and throw it in a garbage can or do whatever. They're physically in the building. It's the ones coming from outside the building or possibly in the building on your network somewhere that's physically unsecure. And all those areas were protected. All of the Wi-Fi stuff is completely protected. The Bluetooth connections have security built in as well. So we feel very strong about security. It's educating our clients. It's working with IT departments. Security is a whole. It's a whole framework. The tech part of it is just one small slice of the security pie. It's getting everybody on board, knowing what to do, what not to do, what technologies to keep enabled, make sure you don't, turn this stuff off, because this stuff is here protecting you. So the real challenge to us in security is not the technology side, it's the education and implementation side.
Yeah, I'm with you. And something we always tell our potential customers is, look, if your IT team wants to be involved, let's get them involved early. And I imagine with wireless networks and wireless devices, it's probably going to be another step up in terms of IT's involvement with that initial engagement to get everything going. And then on an ongoing basis, is there any concern of being able to troubleshoot these devices any differently than you would a wired device?
Well, one of the things that I demanded is that we have tools to troubleshoot connections. So one of the things that we're promoting is what we're calling a wireless survey kit. So the phone mobile app has a menu option. You download the Computrols app from Apple Store, whatever, and you run it, and there are many options. One of them is called a survey. So what a survey is we take one typical Wi-Fi Bluetooth product and one small Bluetooth sensor product. So one represents a controller, the other one represents a sensor, and you can have multiple of these. And there's special versions of those products that have been adapted just for survey purposes, and they come with a battery. So you can walk around your building and you could place a controller somewhere, and you can place a sensor somewhere, and you take your app out and you run it. You can record signal strength and all. We recommend, especially in this early launch time, that everybody does that, just to get the warm and fuzzy that this will work. If I put a controller here and I put a sensor there, it's going to work. The survey kit has the exact same hardware that the products do. They're just tweaked out to run more thorough tests. That's one of the things that we do. And unlike a phone or something like that where you're moving around, once you install a controller or you install a sensor, they don't move. So unless somebody comes along with a giant radio and clobbers it, or somebody puts up a concrete wall between them, they should run forever. Just like our old stuff, if something goes lost communication, you're going to get an alarm. It's going to turn yellow on the screen in CBAS, and you go out and troubleshoot. But that phone's really going to help you make quick work of troubleshooting any wireless problems.
So it sounds like you've thought through most of those potential challenges that a building engineer would run into. Now, based on our conversation, some of the things to look out for to make sure if you're trying to implement this kind of technology in your building is that your vendor is maybe testing the viability of a connection, that they have some proof of concept when it comes to battery life, as that can be a challenge. And then obviously you want to get IT's buy-in. But can you talk about anything else, or even, you could talk about those, I guess, in greater depth. If you're a facility manager and you're getting pitched wireless technology for your building, what would your advice be in terms of evaluating that vendor and the viability of the solution that they're proposing?
Well, one of the things that I would look for is how many of them have you has this, the potential product, how many have been in a single building? And, like I said, when I went to the Zigbee conference years ago, that's exactly what I was looking for. And I tell people, well, if you've ever done a wireless, let's say in a central plant, sometimes people will do a expensive wireless hop from one side to the other, because getting pipe across that large room could be expensive. And it works, and that, it's a one-off. And okay, great, that works. But imagine that someone told you my wireless devices are 99% accurate, and you have 1,000 of them in a building. That means that at any time, 10 devices are offline. 99% sounds high, but it really isn't high when you really start looking at a modern large building automation system and a number of devices that are out there. So it really needs to be in the 99.999 range, to really feel like, okay, I could just lose the wires now. And again, from the beginning, that was my personal criteria, that it has to be reliable. So obviously, it will not be reliable if you push the engineering to the limits. If you take a controller and you put it on one side of a large floor and you put a sensor on the other side of the floor, it's not going to work. We're trying to come up with guidelines, but it's not really a distance problem. I could go outside in the parking lot and get huge distances. It's all the junk that's between them that might cause you trouble. But again, use a survey kit when you're engineering it. The way we have these devices designed is that when in doubt, add more devices. We have a product called the Core Connector. It's got an Ethernet connection. It's got Wi-Fi. It's got Bluetooth, and it has a serial channel. These things are highly flexible. We call it a connector for that reason. It can connect different things. If I have a controller in one spot, I have a sensor in another spot, and they don't connect with each other, put a connector between it. So there are options to get that reliability really up high, and we've done a lot of work on the reliability. And so if you're looking at other people's products, do they have that level of reliability? Throwing one on a table in your office and saying, "Oh, that looks good. Everything's great. That the application was easy to use. I like the product." But rolling out 100 or 1,000 of those into a building, you could be wrestling with reliability issues every single day if they don't have that 99.99% reliability and tools to help you get there.
So it sounds like getting some metrics around how reliable the product is extremely important, and then understanding the tool set that you have as the building operator when it hits the fan, that you can go and troubleshoot and get this figured out. If a vendor comes in and pitches a wireless solution and doesn't do any kind of survey or test ahead of time, is that a red flag to you, Mike?
Oh, absolutely. Yeah. If they talk about reliability, they don't really have good sort of demo sites where they've done the job and you can see the reliability yourself. I mean, again, reliability is the number one issue when it comes to not using wire and going wireless. There's a thing that I tell a lot of the technicians and engineers on my team. When you work with electricity, it's a little bit strange, and we hire new technicians, that you take a piece of copper and you connect it to a screw. You can't see the electricity going through it. And it sounds kind of dumb, but when you're working with electrical things, you just have to know what's going on in that wire. It's completely abstract, and you have to think about it. I go into an enclosure and I grab a heavy gauge wire. I'm scared because I'm thinking, ooh, that thing's probably got some juice in it, and if I touch it, I might hurt myself. Whereas if I grab little bitty wires and communication wires, and you get a feel for it. But with wire, at least, if you connect one end of a wire to a screw and the other end of a wire to a screw, sure, it's a little abstract, but they're connected. With wireless, that problem just gets worse. You're standing there with a device. There's another device. You don't even know whether it's transmitted. You don't know anything, so it's completely abstract. And so troubleshooting and getting reliability high is tough. You have to give people visualizations. In our software, we show the network, we show signal strength, we show all that stuff. You need to give people the tools to get that reliability up. Now, I think we've done a good job of doing that.
Well, good. Really appreciate the time today, Mike. And certainly I'd like to open the floor for you here to talk about anything you'd like to discuss, anything our facility management audience might benefit from in regards to wireless that we haven't talked about already.
Yeah, I think, we've covered the wireless technology quite well, and the tools and the reliability and so on and so forth. But along with wireless, we're making a philosophical change that is not just about losing the wires and replacing them with wireless connections. The devices themselves are getting smaller. When you don't have wire, it all of a sudden becomes silly to hang a large enclosure on the wall, fill it with stuff all in one place. It becomes much more practical to just take smaller wireless devices and place them on the equipment where you need them. So, for example, in a mechanical room where you'd have a large enclosure, a bunch of pipe coming in, you open it, there's a single large controller with gangs of wires home run to it, going out to sensors. It's not just that you put another large controller in there with a bunch of wireless instead of wire. The entire enclosure disappears. So you place smaller controllers at an actuator motor on a VFD, duct sensors. You literally drill a hole in the duct, you shove it in there, and it's done. There's a battery inside of a little box, and it can measure temperature or humidity or whatever you need. So it turns out there are more devices if you do it this way. And again, reliability and so on and so forth. There are more devices. They're just where you need, and the labor is reduced. So I kind of want to give everybody that vision of not only do the wires go away, the pipe goes away, the enclosures go away, and the big bulky equipment goes away. We're trying to go faster, smaller, and more numerous devices.
So you see the electrical closets going from the size of your wife's closet to the size of your closet then, Mike. Is that fair to say?
Well, yeah, I that would be fair to say, yes.
Mike, thank you again. This has been really great. Obviously, you and I have had the chance to talk about this many times over, but this is exactly what I wanted to bring to our podcast audience, just to give them this additional background on wireless devices. And I think that you've done a great job with that today. So thank you again for joining us and taking the time to do this.
Appreciate it, Scott. Looking forward to rolling this stuff out and having fun. So,
absolutely. And for all our facility managers out there, there's a lot to be excited about with wireless here. It's certainly comes with its own challenges. Based on what Mike's told us today, we've gotten pretty far down the line with this approach, and it's an exciting look for new buildings and even existing buildings. And I think that that's an application where Mike is talking about the infrastructure you need to implement these, and it's not huge. It's getting that TCP/IP backbone in the building, and then from there really opens things up. But again, thank you to Mike Donlon of Computrols for joining us today. This is Scott Holstein with the Building Technology Podcast signing off.